Welcome to this video on what is a confidence interval. By the end of this video, you should be able to identify an appropriate point estimator and calculate the value of a point estimate. You should be able to interpret a confidence interval in context. You should be able to determine the point estimate and margin of error from a confidence interval, and you should be able to use a confidence interval to make a decision about a value of a parameter. All right, so today, the scenario says for a new reward system, you get to pick a bead from a jar, and if you get a red bead, you get a piece of candy. And if you don't win a prize. So the question is, what are the chances that a student chooses a red bead? So if I just have a bunch of beads, each group, so we're not going to do this in group, we're going to create a confidence interval to estimate the true proportion of red beads. So the group with the smallest interval then captures the true proportion. Okay, so we want to make an interval of plausible values that could capture the true population proportion. All right, so I took a sample of beads for us. And so I had this cup of beads, and remember, red is what we're looking for. And I had taken a sample of 20. And when I got that, I got 7 red beads out of the 20 that I pulled out. So when we reduce that, it's going to be a probability of 0.35. Remember, that's going to be your p-hat because it's from a sample. That's our point estimate. Okay, that's what we're estimating the true proportion of red beads to be. So let's go back and identify our population. So our population is going to be all the beads in the cup. The sample is 20 beads from the cup. The parameter, the number that describes the population. I don't know. Well, that's what we're trying to do. We don't actually know what that one is. Okay, and then we had a sample, a statistic. We had 0.35. All right, so that 0.35, remember we called that the point estimate. That's what we're estimating the population to be right now. And then our parameter, P equals the true proportion of red beads. We don't know what it is, so we're just defining what it is. It's the true proportion of red beads. All right, so what we're going to do now is we're going to make a margin. And so I want you to think about it for just a second and make a little guess. Stop the video and make a little guess here of you want to come up with a number that you're going to add and subtract a margin of error to your point estimate to come up with a plausible value of values that for what's the true population parameter here. And so we want to use the smallest that you can. So I want you to kind of think about it, but you want to be able to capture it too, because we don't actually know what it is. So it can't be, you don't want it to necessarily be too small either. So stop the video and take a think about it. Write down what you think. All right, so for the point estimate, I'm going to show you what I did. I said I'm going to add or subtract 0.10. And the reason I chose that, because it says you want to explain why, that is just 2 more red beads each way. And to me, it just seemed possible. So that was my whole idea. It's something that I thought that I could get, that maybe would be likely to get, that it wouldn't be too unusual. Okay, so that's why I chose that. So what I want you to do is I want you to take your point estimate. You don't have to use mine. Your point estimate, well, the 0.35 is the point estimate, your margin of error, and add and subtract it. So our point estimate was 0.35. I had a margin of error of 0.10. So when I add or subtract this, I get an interval of 0.25 to 0.45. So this is an interval of what I think are plausible outcomes and a plausible population proportion. Okay? Now, this is going to lead into something called a confidence interval. You're going to get a range of numbers, and a confidence interval is found by taking your point estimate plus or minus some margin of error. So remember when we were talking margin of errors before, when we were talking about the presidential polls, we would take whatever the poll results were and add or subtract the margin of error to give the list of plausible values. So we're just going to be taking that idea a little bit further. Now, right over here on the edge, I want you to just come up with how confident do you feel that this interval, or whatever your interval is, captures the true population proportion. How confident are you feeling about that? Pause the video and think about it a second. Okay, so I'm guessing 90%. I'm feeling 90% confident that my interval is going to capture. You might feel a different percentage because your interval might be different if you used, depending on what you guessed for a margin of error. Now I'm going to give you a math lib of how we would want to interpret this, okay? So we're going to say we are, and then whatever your percentage is, I put 90, whatever your percentage is, we are 90% confident the interval, and I have this interval, if you used a different margin of error, you'll have a different one, 0.25 to 0.45 captures the true proportion of red beads in the cup. Okay, so this is one of those math libs. So I put in a confidence. How confident do I feel? Now, confidence in statistics, we're going to get more into this, means something actually. And then the interval of the lower to the higher captures, and then I have the context. Okay, so we have one group, and they got an interval of 0.27 to 0.33. What was their point estimate and what was their margin of error? So I'm wanting to know the point estimate. The point estimate, which is going to be halfway between these two. And I'm wanting to know the margin of error is what number did you add to and subtract from that point estimate to get those two intervals. So your point estimate is halfway. So we're going to take the two numbers, 0.27 and 0.33. We're going to add them together and divide by 2 to get us the halfway spot. So their point estimate was 0.3. So that means they would have had a p-hat of 3 in their sample. Okay, now to figure out what they added and subtracted, you could look at that and probably figure it out, but sometimes the numbers are not that clear, so there's a particular way that makes sense. I want to know the distance is being added, and half of it's being added on each side, added and subtracted. So to find the margin of error, you're going to subtract these two numbers. Take the bigger one minus the smaller one, and divide that by 2, because that will tell you the two pieces, and I got 0.03. So you could look at 0.3 and go, oh well, if I just add and subtract 0.03, I'll be there. But I wanted to make sure that you understood kind of the way. Now, another group claims that the true proportion of red beads is 0.25. Does your interval support this or deny this claim, and why? Well, my interval was 0.25 to 0.45. Their claim was 0.25, so I'm going to say In my case, yes, my interval supports because 0.25 is in it. But what if your interval doesn't have 0.25 in it? Well, you'll say, no, your interval does not support the claim because it can't contain 0.25. So if 0.25 was in the interval that you made right here, yes, your interval supports the claim because 0.25 is in the interval. If 0.25 is not in your interval, then you're going to say, no, my interval does not support the claim because 0.25 is not in the interval. So when we make these intervals, they should contain all plausible values. So we're going to make these confidence intervals. And they should contain all plausible values. So by plausible values, I don't mean all possible values. I don't necessarily want 100% confidence because I made my interval so huge that no matter what the answer is, I'm going to be able to capture it. You want to narrow it down so it gives you a little bit of information. So say we were listening to the news in the morning and the weather guy said the temperature tomorrow is going to be negative 50 degrees to 150 degrees. Okay, he is not wrong. I'm 100% confident he will be accurate in his forecast. However, that doesn't help me at all. It doesn't help me plan my day. It doesn't help me plan what I need to wear or anything like that. So what the weatherman does is he gives you a smaller range. I think it's going to be between this temperature and this temperature. It's going to be between, this morning it was like 30 degrees with a high of 50 degrees. So that gives me a really good idea of I should make sure I have a jacket. It's going to be cold in the morning. But maybe I have a lighter shirt or short sleeves underneath because it's going to be a lot warmer in the afternoon for January. So you need to have a narrower interval to help you kind of understand and get a better idea. So that's what we're talking about with confidence intervals contain plausible values, not all possible values. So let's go ahead and flip this over to summarize. All right, there's 3 things that I want to tell you. And this should give you enough space to write. So the first thing is your point estimate. Okay, so a point estimate is a statistic that provides a reasonable estimate about the population parameter. A statistic that provides a reasonable estimate about the population parameter. And the ones that we have most often talked about, so your point estimate, we have talked about both sample proportions and sample means. So we're going to continue to use those. So these were our point estimates. And they are to help us understand better the parameter. So we want the population proportion or the population mean. Okay. Now, for a confidence interval, and we're going to name them AB. If you want to find the point estimate, you just are going to add A and B together and divide by 2 because it's halfway between A and B. And if you want to find the margin of error, you're going to find the distance between A and B and half that. Okay? I want to note again that a confidence interval contains all plausible values. Okay. And then the last piece is your interpretation. We're going to need to be using these when we answer about our confidence intervals. You are going to say, we are blank % confident, and then we'll talk about how you get that number. The interval blank to blank captures the true and then whatever parameter in context. Okay, so you'll fill in that spot too, whatever it is in context. So we are blank % confident the interval blank to blank captures the true population parameter in context. All right, so what I want you to do is try the check your understanding and check your answers. The key will be on Canvas. The one thing I want to point out is right here, it doesn't say it super overt, but right here it says a majority of adults. I'm going to just give you a hint. That means greater than 50%. That should help you with your proportion. Let me know if you have any questions. Looking forward to seeing you in class.